Okay, so good day, everybody. So this is joint work with my former master student Constante Dietrich, Katharina Kromholz, and Kevin Borgolte from Berlin Hochschule für Technik, CISPR Helmholtz Center, and Princeton University. And I'm Tobias Fiebeck, who will be presenting today because Constanze actually decided to go for greener pastures in industry, but she left me some comics to show you in this presentation. So let's quickly start. Like, what are security misconfigurations? Well, security misconfigurations are basically simple errors which impact security. So security falls off the ledge because something simple goes wrong. And something we see quite a lot is that this something is like MongoDB or some NoSQL database. So a service that is exposed to the internet without a password set, because a firewall configuration had a typo, because small things went wrong. And this is not only something we talk about theoretically, but if we're looking at real-world incidents, these actually do happen. So one of the most famous ones in the recent past was probably Equifax. You might say like Equifax, that was an update that was probably a completely complex infrastructure and they just couldn't update. No, actually the Equifax CEO just went in front of the press and was like, yeah, well, there was this one guy who simply forgot to install the update. He should have done it, but well, he forgot. So for our work, what did we want to know? So if we have security misconfigurations here, we want to know why they happen and how we can actually prevent them from happening. And the approach we took for this is that we started with exploratory interviews. And as we wanted to talk to system operators as the major actors in, well, operating systems, we had to do this via IRC. So IRC, probably most people don't know this. It's a little bit like Slack, but it doesn't eat all your RAM. And we actually got quite a lot of useful, well, rants, inputs, insights. So based on this, we developed a questionnaire study to get a more quantitative view on operators' perspective and, well, experiences with security misconfigurations. So how do you get operators to participate in your survey? Well, we went to the local regulars table of system operators and asked them, like, how can we get a lot of you to actually fill out a survey? And they suggested that we write to a lot of operating mailing lists, which we did, and actually cooperate with organizations, industry organizations that do have contact with a lot of operators. And this was, in fact, the RIPE NCC and APNIC, which are the local IP address registries for Europe, Middle East, and APNIC for Asia Pacific region. And we, of course, used Twitter. Using this, running a survey we had designed, over 4 weeks, we got 221 valid responses. So there were a couple of responses where things went wrong, but overall, we ended up with 221 valid ones. So let's get into what we found. So demographics-wise, we do have a huge bias towards Europe, which is probably due to us heavily relying on the RIPE NCC to disseminate our survey. But we did have seizable impact from also North America, Asia, Australia, and South America. Sadly, there were no responses from Africa, which might actually be an interesting point for further work. The other demographic aspects, like age, was normally distributed. Experience, actually more than half of the operators do have more than 10 years of experience. And more than half of the operators actually do have a university background. What you should note is that a PhD actually does not really mean that you do have high chances of becoming an operator. So you should have probably stopped with your master then. So what types of operators did we have? Half of the operators that responded to our surveys, especially based on that we used IP address organizations, were actually working with internet service providers of some form. Then we had, of the remaining half, roughly 1/6 total non-IT organizations operators. So like company running a business producing furniture. 1/6 for the government sector, and 1/6 for IT companies, so like an SaaS provider. When we think about misconfigurations, the first thing we ask them is like, did you actually encounter them? Like have you seen misconfigurations? And in general, a little bit over 75% of our operators said like, well, I've seen misconfigurations and I actually made it myself. And a little bit below 25% say like, yeah, no, not that I know of. However, when we start asking them about specific misconfigurations, we suddenly nearly land at 90% of operators who did something themselves. An interesting thing here is, however, that if we ask them whether those misconfigurations they made led to a security incident, only like 1/3 was like, okay, this was actually leading to a security incident, which, given the severity of incidents in the past based on security misconfigurations, paints a rather dire picture. If we actually take a look at what Alyssa said earlier, self-confirmation bias, and ask whether they know somebody who eventually maybe made a misconfiguration, we finally end up with just one operator claiming that they have never encountered a security misconfiguration. So, to summarize this slide, security misconfigurations, having them does not necessarily mean that you land at an incident. We also ask about specific misconfiguration types. So, for example, missing isolation. So that's basically broken firewalling, weak passwords, etc. And first thing, again, self-confirmation bias here is that certain types of misconfigurations seem to be a little bit more frequent in the encountered. So it's somebody else done misconfigurations. For example, weak passwords. While this effect is not as strong with, for example, delayed or missing updates. So what we assume is that it works kind of the following. I would never use admin as a password, except on that one test machine I'm running in the lab. It's only academic code. However, I mean, who's installing updates? Like everyone is skipping them, so that's fine. We also asked operators about factors they see as contributing. And important note here, actually, this is not full root causes. This is contributing factors. And I think it would be a little bit too long to go through all of these. So let's just take a look at like the top and the bottom answer. So we asked 100 system operators, what do they think is a contributing factor? Top answer for personal factors was missing knowledge. So just not having the knowledge about the system you're operating to run it securely. Top answer for environmental reasons is that you have sole responsibility over a system, so there's no second person taking a look. And I mean, we all know this from the papers we are writing. They always get better if somebody else is checking them. And top systemic reason is using default settings. And we had quite a few software packages, for example, Redis, that have been delivered with really, really insane defaults. Thinking about the things that system operators actually perceived as less important reasons for security misconfigurations, we surprisingly find poor online resources, which I find a little bit counterintuitive, because especially for programming, we have a lot of related work. Likert et al., for example, that took a look at how this is with programming errors. But apparently system administrators for system administration do not really see bad how-tos as a really contributing factor. For the environmental reasons, again, surprisingly, system administrators are not convinced that insufficient funding is a major contributing factor, which might be interwebbed. So having sole responsibility, if there is no funding to have a colleague, you will probably not have a colleague. But at least in their perception, this is not a major contributing factor. And for the systemic reason, misleading conventions, which again, for me, if I look at it from the outside, would be like a top reason. Like you're doing things one way, you're doing things another way, you're doing things, well, different in different systems. Actually, they don't see this as a really, really contributing factor to security misconfigurations. In addition, we also asked operators how they perceived certain factors specifically. And for that, we built a Likert scale. So as Alyssa already explained, it's basically a scale, usually 5 items, equally spaced from disagreement to agreement, including also an opt-out option. And the first opinion we asked operators about is whether they think that their managers do know what they are doing. Right? I think we all have that one manager we think about. when we're thinking about a manager who doesn't know what they are doing. But actually, we found a difference here between operators from different organization types. So if you have operators from organizations whose core business is not IT or the government sector, they are significantly, well, within our sample, less convinced that their superiors know what they're doing compared to operators which are from a background of a company that does something with technology. So an IT service, well, an internet service provider or an IT organization, which might in fact relate to impact of misconfigurations, because when we ask operators what changed after they found a security misconfiguration, like over 150 of our 221 respondents were like, okay, after we hit a security misconfiguration, things got better, or security posture got better. If we asked them whether the impact of having an actual security incident was higher, the same, or less, again, people were mostly convinced that having an actual incident would, again, improve security posture. Other note, more senior operators seem to distrust their tools, because if we look at the junior operators, so people who have less than 3 years experience in our sample, we see that they are still kind of convinced that their tools are trustworthy. So the really junior people are like, yeah, it's probably kind of okay. The a little bit more senior people are like, yeah, it's okay-ish. Nah, no, probably not really. But if we're then looking at the people who have a lot of experience, they are like, no, don't trust your tools, never. And we assume that this is due to older people having had a lot more time to actually be burned by the tools they're using. The things falling there is, by the way, a funny version of a certain network vendor's logo. Took some time, yeah. So another thing is that operators seem to like blameless postmortems. So if we ask them whether they think that blameless postmortems are a useful tool, there was like really huge agreement. So an average of 1.274 for a scale that ends at 2 is actually quite large. However, we also asked them whether they think that the companies they are working in is budgeting for error. And there we had a close to similarly strong disagreement. This is actually dramatic, because if you're not budgeting for error, you cannot do a blameless postmortem. Because if you have an incident and you do not have any budget to account for that, well, it has to come from somewhere. The budget has to come from somewhere. The making up has to come from somewhere. And then you have to start to blame somebody. So let's go back at how we could actually do something about this. So based on our findings, we found that one thing we could actually do to make operators' life easier and less misconfiguration prone is to do automation, right? Because there's a lot of things that can go wrong if you have to install the same database server on 100, 200, 300 virtual machines by hand every time. Like, I cannot type a straight sentence without making a typo. So having automation there can actually make systems a lot more secure. Similarly, we should go for better documentation, right? Because I don't know how you work when you're setting up infrastructure for your research. I know how I do it. And I usually am convinced that I will write good documentation when I start. Time passes. I think we all know the problem. Next thing is clear and shared responsibilities. And this is actually an interesting one, because you do not only have to have clear responsibilities, because otherwise two people are really convinced that the other one will take care of that update. You also have to have shared responsibilities, because if it's only clear that like this one person is responsible for an update, as in the case of Equifax, and that one person doesn't do it, or that one person got sick, that one person is on holidays, you will actually have a problem. Another thing is better processes. And processes, so we are probably mostly working in universities, so we know how processes can look like. And that's actually not the kind of processes we mean. We mean better processes, not more processes. To simplify processes to actually make being secure, doing the secure thing, doing the right thing in system administration, an easy thing to do. An idea Constanze had during this research, especially based on the responses that were like, well, our managers could be more aware, could know better what we're doing, could know better what would be the impact of a security incident, was to do actually incident RPGs. So you do role playing, you basically do fire drills to figure out what you have to do if something goes wrong, but also what impact that would have on your organization. So she would actually go as far as like putting in fake newspaper articles so the managers can see like, okay, we lost like all our customers' data, or we had a newspaper article claiming that we implemented small chips on our mainboards and our stock price dropped like 50%. And the last thing, and that was actually really important for Constanze that I make this point. We have to enable operators to do like really, really blameless postmortems, like really blameless. So assuming at the time of the postmortem that everyone during the incident was acting in their best faith and knowledge. And with that, I was actually a little bit faster than anticipated. But you can follow all 4 authors on Twitter if you want, and you can actually check out Constanze's talk, which she held yesterday at the RIPE NCC meeting in Amsterdam, at the following URL. And before I use the little bit more time of questions, I will do a quick commercial break, because actually, Katarina over there, raise your arm, that one, just started at CISPR, and she's planning to hire PhDs and postdocs. So that one over there at the slide, this one could actually be you doing research like this with Katarina. So with that, thank you again, and I'm happy to take your questions.
So I'll start with a dumb question. Where did you get all the great art?
Constanze drew it.
What's that?
Constanze drew it. Constanze is a really, really gifted comic drawer, and it was actually part of our survey. So we kind of established her with the comics as a brand in the SysOps community, and actually used it throughout our survey. So it's all self-drawn by her.
Nice.
Right. Great talk. Tudor Dumitris from the University of Maryland. Yeah, we think of system administrators of professionals who behave rationally. They make these decisions, based on rational criteria. But do you think that some of the factors that were discussed in the first talk in the session might affect some of this behavior?
Yes, of course. So I think I also highlighted the point that we do actually see things that can be really easily explained with self-reporting bias. Especially in the types of misconfigurations, operators tend to admit to have done themselves and tend to, claim they only saw other people do.
Okay.
I'm not sure if I got the right impression, but I think I have this sad, lonely feeling for all that non-IT operators. They have sole responsibility and their managers don't understand what they do. Should I really feel bad for these people? Is it sort of as bleak as maybe I kind of gleaned from this?
Well, I would say there's always room for improvement. So it always depends on your company. So from my practical industry experience myself, I know that there's also IT companies where people are not really happy and are
So I should feel bad for everyone.
Yes. Well, yes, and there's also organizations that are doing nothing with IT in their core business, which actually do have a really well-structured and working IT. But the general theme we saw is that in non-IT organizations, it's a little bit harder to get managers that know what they're doing.
So James Landry, Lincoln Laboratory. So I really appreciate the talk, and I appreciate all the extra work that went into the artwork. I know it's not easy. In the previous chart, when you're laying out all 6 of the potential misconfiguration mitigations, how do you choose among them? I mean, a lot of these are very intensive, change the organization, do things very differently, cost money, cost time. Is there some way to prioritize, or a way to think about which ones you would roll out first in terms of what people would handle better? Do you have any thoughts on how you would apply the mitigations?
So when we looked at what made security misconfigurations to be discovered, audits were quite high at the top. And within that sense, I think the blameless postmortem culture is the first thing you should do.
Okay.
Because if you start finding things, you should implement a culture where finding things does not make people unhappy, and brings you into a position where you can actually make a positive change and ensure that things only happen once. So I think doing the blameless postmortems and actually making sure that you have a blameless culture and are not only talking about one is like the first and most important thing you have to do.
Yeah, but that seems really hard, actually, to like create an actual blameless postmortem. I mean, I people talk about it, but I think a lot of it's bullshit, obviously. So do you have sort of ideas about how to do that, or?
Well, that's actually the matter of current work. So figuring out like how socially sysops interact, and how we can make that better.
So if you look at how safety science in general works, and like airplanes, for example, right? Usually they don't start blaming actually like the pilot if a mistake happens, but they're trying to figure out what was the process that led to the pilot failing.
Oh yeah, I mean, it's certainly done in other industries, but I'm not sure it's really propagated to IT
And
very well.
if we would be flying planes like we run IT systems, they would be coming down a lot more often, and I think then they will drop the blameless part.
Okay. When it comes to mitigations, I noticed that defense in depth was not listed there, in the sense that if you have a defense in depth security architecture, a misconfiguration in one place is not going to do a lot of damage. And so I don't know whether that is something that would fit into your typology at all, but from my point of view, I see misconfigurations as inevitable, and the task is to design the system to be able to tolerate some.
Yes, that's also part of the opportunities we have, but we still have to also address the human part of this.
Of course.
Lorenzo Di Carli, WPI. You got a little bit to that, maybe indirectly, but I was curious if you got a sense of whether there are certain management decisions that make operator mistakes more likely.
Well, our operators said that financial decisions are not a point, but more like, understaffing. So in the end, it kind of goes towards the same thing. And I think like the staffing issue and the time pressure things are the most problematic issues we have for sysops.
So fundamentally not allocating enough resources to deal with this. Okay.
So, thank you.